Okay, today we're going to pull back the curtain on a principle of physics that is so powerful, it honestly feels like a superpower. Seriously, it's this incredible force multiplier that's hiding all around us in plain sight. And I bet you've already used it today. So, what is this hidden force? Have you ever been at a mechanic's shop and just watched them? They hit a button or step on a pedal, and this massive 2-ton car just floats up into the air. It looks like magic, doesn't it? How on earth can such a small effort lift thousands of pounds of steel? What's the secret? Well, you guessed it, it's not magic. It's physics. The secret behind this amazing feat of strength is actually a really simple, super elegant principle that was figured out way back in the 17th century by a guy named Blaise Pascal. It's called Pascal's law, and trust me, it's the key to understanding so much of the world around us. So what exactly is this law? Okay, put simply, it just says that if you have a fluid, like oil or water, trapped inside a closed container, and you push on it, that push gets felt equally everywhere inside. The key things to remember are confined fluid, it has to be trapped, and that the pressure is transmitted equally. Think about squeezing a water balloon. You squeeze one spot, but the whole balloon bulges out, right? That's the idea. And what's wild is that the math behind us is so simple. Pressure, which we call P, is just the force F that you're applying divided by the area, A, you're pushing on. That's it. This one little formula is the entire secret to multiplying your own strength. So let's put this into practice. Let's go back to that mechanic's garage and finally solve the mystery of the floating car. Because once you understand Pascal's simple idea, you can see exactly how we can become superhuman. All right, here's the breakdown. Imagine you apply a little bit of force on a small piston. Let's say its area is just 1 square inch. That little push creates a certain amount of pressure in the hydraulic fluid. Now, thanks to Pascal's law, that exact same pressure travels through the fluid and pushes up on a much bigger piston on the other side, say one with an area of 100 square inches. You've got the same pressure acting over a way bigger area, which creates a way bigger force, 100 times bigger in this example. And that's the whole trick right there. You put in a small force over a small area, and what you get out is a massive force over a large area. It's a force multiplier. You can lift something insanely heavy with just a tiny push. It's genius. But multiplying force isn't the only incredible thing Pascal's law can do. It's also the very reason your car can stop safely and reliably every single time. So let's look at another place you use it every day, the hydraulic brakes in your car. Okay, so when you hit the brake pedal, you're really just pushing a small piston. That creates pressure in your brake fluid. And just like with the car lift, that pressure is transmitted all through the brake lines. But here's the magic for brakes. That pressure is sent equally to the braking system on all 4 of your wheels, all at the exact same moment. And this is absolutely crucial. This equal distribution of pressure means every single wheel gets the exact same amount of stopping power at the exact same time. That uniform braking is what keeps your car from pulling to one side or, even worse, spinning out when you need to stop fast. It's an incredibly reliable system for something so vital to our safety. So let's just step back for a second. We've just seen one simple law of physics being used in 2 completely different but equally powerful ways. It's just a fantastic example of how a single, fundamental idea can be engineered to do totally different jobs. Let's look at them side by side. With the hydraulic lift, we're using Pascal's law for force multiplication. We're turning a small push into a huge lift. But with hydraulic brakes, we're using that same law for force distribution. We're taking one single push and spreading it perfectly evenly across 4 different points. 2 incredible powers, all from one elegant, simple idea. And that really makes you wonder, doesn't it? Pascal's law is just one of these amazing principles working behind the scenes, performing what feels like magic every single day. So the next time you see a car rising up at a garage or you tap your brakes, you'll know the secret. But the real question is, what other physics superpowers are hiding in plain sight, just waiting for us to notice?